Alright, welcome my true Chemilites. Today we are going to be looking at what? Alkynes. And we've gone a long way by looking at alkanes. Alkanes, if you've not watched this video, you can go and check them out. But now we're going to be looking at alkynes. Okay? Now, we have a lot of things we have to look at in alkynes. Apart from the introduction and things we have to note, we have to still look into the first member of the alkyne family. Aside from that, we have to look at the types of alkynes we have. It's not like alkanes that has one particular type. This one has two types. Okay, we're going to look into that. And aside from that, we're going to also look into what the cyclo alkynes, and further we'll see how far we can go into this topic. Okay, now first of all, what we have to know about these alkynes is that alkynes are organic compounds which possess at least one triple bond in its carbon to carbon chain. Okay, it has to possess at least one triple bond. Now what does that tell us? That tells us that there can actually be more than one triple bond in a particular alkyne. So now, as like for example, as we are seeing this guy, there's a possibility that we can also have a triple bond here. You get me? Now, aside from that, let's look at our first intros. Now we're going to see that first of all, the number one thing we have to know about these guys, unlike the alkanes that are saturated, alkynes are a little bit unsaturated but at a limit. But these guys are the most unsaturated. So we have to know that alkynes are what? Unsaturated. Now, I've said that in the definition, they must have at least one triple bond in a long carbon chain. Now, inside this triple bond, what do we have to note? Normally, we know that there must be a pi bond here and there must be a sigma bond. But which and which is the sigma bond? Now, we have two pi bonds in this triple bond, and we now have one sigma bond. Please note that sometimes it can be confusing. You might think it's actually two sigma bond, like your logic normally tells you that, but note it, two pi bond and what? One sigma bond. Okay, now it performs the sp hybridization. Just note that it's a very important point. It's a popular question, so note it. Now the most important inside everything here is the general formula. If you know the general formula, it will be easier for you to identify the members of this homologous family. Okay, it's CnH2n minus 2. Now we also have what? Now I want to put this in bracket and take note of it. Later we're going to look into it. I said we're going to touch what? Cyclo Alkynes. Now the formula for the cyclo alkyne is what? CnH2n minus what? Minus 4. Now, the cyclo alkynes, I will get into that. Just notice this formula. Later, we're going to come back to it. Okay? Aside from that, it has a bond angle of what? 180 degrees. These are points very, very essential. They are mostly asking something like posterior, and sometimes you might just mistakenly see them in jam. Okay? Now, their molecule, the shape of their molecule is actually linear. Okay? Now, we are here at what? Ethyne. This is very special because ethyne is the first member, or can we say the simplest member of the what? Alkyne family. Now you might be wondering, is it not, why didn't we start from why didn't we start from ethyne? Okay, now look at it. If we start from ethyne, how is it going to work? Like, imagine it. Let's try to do something here. Okay, let's try to draw something. First of all, put our carbon. Now, if we put our triple bond, okay, if we try to now let's try to, we can't put any carbon because it's meant in one, right? So if we now put hydrogen, it's not still okay. What is this? We have failed actually to classify this guy under alkynes, because it's no longer carbon to carbon triple bond. It's now carbon to hydrogen triple bond. And now we now see that there is nothing like what? Methane. Now that is why we came to what? The what they call it, the second carbon. Now we have to count from the second carbon as the first. Do we understand? Now it represents 2. So if we impute this formula into 2, that is, as our n, if we denote our n to be what? 2, it will be what? Now Our formula will be C2, then hydrogen. Now it will now be 2. If n is equal to 2, 2 times 2 will give us 2 times 2 will give us what? 4, right? Minus 2. Sorry, I was pointing this side actually. This is what we are looking at. These are this for the cyclo alkanes. Remember, don't forget about that. Okay? So now 2 times 2 will give us what? 4. 4 minus 2 will give us what? 2. So that's why we now have C2H2 as our formula. But that's not all. We have to what? We have to write out the formula, the structural formula of ethyne. Now, ethyne goes like this. We can say this. First of all, we put our carbon to carbon what? Triple bond, the most important thing. If it's not linked to another carbon, it's no longer an alkyne. Now, we have to just balance our hydrogen. Now, from the look of things, we can see closely that this thing is actually balanced. 1, 2, 3, 4. It's tetrahedrally linked together. Same thing goes to the other side. Now, what are these interesting compounds we have here? They are all what? Alkynes. But there's something wrong with them. They are not the same, obviously, but they have the same amount of what? Carbons. Now, what do we see here? Now we have to go back to when I said we have types of alkynes. Now, alkynes are of two types. We have the internal alkynes and the most interesting one called what? The terminal alkynes. Now, in the terminal alkynes, the triple bond is positioned at the first carbon. Obviously, from my definition, we know that this guy is what? The terminal alkynes. This guy is the terminal alkyne. Now, this guy, from the look of things, without any definition, obviously is not at the end. So this guy is the internal alkyne. Now, why is this guy? These guys are interesting, as I said earlier. They are interesting because they are very reactive compared to this guy. Now, terminal alkynes are reactive based on what? Because they possess a replaceable hydrogen ion. Now, the most interesting part about this guy because it can be what? Displaced. It can be replaced by what? It can be replaced by a very reactive metal like those of the group 1 metals or alkali earth metals like sodium, potassium. It can actually displace this hydrogen. That's why they are very reactive and acidic. But now, looking at this guy, the internal alkynes, note it's very important because if you know this, we're actually going to see that when we're talking about the preparation and the reaction of alkynes. Now, because there are some reactions this guy cannot undergo, but this guy, terminal alkynes, can undergo them. But this one, it's not acidic, neither is it too reactive. So please note that it is because of the replaceable what? Hydrogen ion in them. That is why they are so reactive and acidic. Now, first of all, before we go further, I know we are not going to be looking deeply into what naming alkynes here, but I'm going to name these alkynes for you. Then in the next video, we are going to be looking at naming alkynes, and also we are going to be looking into preparation of alkynes in another video, and also looking at reactions of alkynes. Now, but here, let's just look at this one. How do we name this guy? First of all, in naming an alkyne, the triple bond is what? The priority. The triple bond is the priority. So now, what do we do? Obviously, we have to count from this side. Now we can count from this side as what? 1, 2, 3, 4. Obviously, it is in the first carbon, right? It is the first carbon. So we can easily name this guy as what? Butane or but1-ine. You understand me? We can simply name this guy as but1-ine. Alright? Okay? We name it what? But1-ine. Or we'll just call it but-ine. Okay? Why do we call it but? Obviously, it has 4 carbons, and 4 carbons is represented by what? But, as 2 carbons are represented as earth. Okay, so now this guy is also but there is a difference. The position of the triple bond is in the what? Is in the middle. That is why we call them the internal alkynes. Now, what do? We count from any side because they're actually equal. So we count 1, 2, 3, 4. So we can just say 2 what? We can easily say two. Sorry, we can. I forgot. It's not a substituent. Sorry. So we're going to call it both what? Both two I. It's as simple as that. Okay. It's as simple as that. Both two I. And this one is both one in. This guy is called both two I. All right. So this guy can also be called butane, but if you see butan and it's also correct. All right. So now what do? We have to look at alkynes properly. We expatiate on him. Now looking at ethyl as a case study, what do we have here? We obviously have first of all our structure, and from the structure we said some stuff earlier about the structure of what ethyl, but that's not all about ethyl. It has characteristics. Okay, so now we're going to look at those characteristics. As we can see, these two correspond to each other: two carbon, two hydrogen, two hydrogen. So now let's look at the characteristics. Obviously, the first thing we have to note about this guy is that he has a sweet smell. Don't forget, it has a sweet smell. Sometimes they can frame question and say an organic compound or an hydrocarbon with a sweet smell and formula of C2H2, or they might not even put the formula and tell you to and give you options and you choose from those options. So note clearly. Now it's also colorless. Aside from its color, it's spiraling soluble in water. Please note this word, spiraling. Now what does this word mean? It means that it's actually not soluble. It's not soluble, it's soluble. So you understand me? Like it's not too soluble. Little, like if you put it in water, it will dissolve a little bit, but not too much. Note it. Okay? So next thing we have to note is the component of what? Oxyethyl flame. Now what is oxyethyl flame? Oxyethyl flame is a flame used in what? Cutting and welding of metals. Now, this oxyethyl flame can also be called what? Oxyacetylene flame. That was the old name. So now, if you don't see ethyl, if you see acetylene, please, we are talking about what? The same thing. Don't forget. Ethyl is also called acetylene. So now, that is why this guy can also be called oxyacetylene flame. Now, there is another flame that also serve the same purpose as oxyethyl flame. It's called oxyhydrogen flame. But now between the two of them, oxyhydrogen flame is used in welding and cutting metals too. But between oxyhydrogen flame and oxyethyl flame, which of them is hotter, which of them is more efficient, is obviously this guy here, oxyethyl flame or oxyacetylene flame, as the former name, is most effective. Okay, so now finally, fuel for minus lab, please. You see this equation? You see this equation? So any point I'm giving, please be noting that this equation, this one comes out very well. Which organic compound is used for a minus lab? It is ethyl or what? Acetylene. Now you might get confused sometimes because when we're talking about what? Alkenes, the what? ENEs. The alkenes. When we're talking about the alkenes, ethene, when we're talking about their first member, we said what? It's used in ripening of fruit. So please note the difference. That guy is what? Used in what? Ripening of fruit. But this guy here is used in what? For minor slam. Note it. YNE used in what? Minor slam. ENE used in what? Ripening, to hasten the ripening of fruit. So I think that's all we need to know about the first member or the simplest member of what? Alkynes family. Alright, now looking at Cyclic Alkynes as a case study, what do we have to know? There are a lot of things we have to know. First of all, I talked about the general formula of the Cyclic Alkynes in the beginning of this class. Now look at the CnH2n minus 4, a difference of what? 2 hydrogen from our what? That is from the normal original alkynes. Now let's look at these examples. Now first thing we have to note about the Cyclic Alkynes is that it starts from what? The third carbon. Now it can't work as the first carbon, neither can it work as the second carbon, because now if we try to do something like this, if we have something like this, normally it can't work obviously. Then if we try to even add another carbon, what is going to happen? It can't be cyclo because it's just a straight line. So it has to join itself together before it can be called what? Cyclic Alkynes. So now what else do we do? Now This guy being the first member, because we said we start from 3 carbon, alright? So we now call this guy our first member. After the third carbon, we have the fourth carbon. We call this guy what? Our second member. And what? This guy is the third member. And so on and so forth. This guy is just a branched cyclic what? Alkynes. Alright, so now now what do we then do? We have to what? Name these guys. We have to name them, obviously. So now what do we do? Remember, these are just the names. Comparing them with what? We are comparing them as the first member, the second member, and the third member of the what? Cyclic Alkynes. They are obviously what? 3 carbon, 4 carbon, and what? 5 carbons. Okay? So now, if we follow our general formula, what is going to happen here? Now, following as we know, we are using 3 as a case study here. So 3 now times this will give us our 3 carbon. If n is 3 here, 3 times 2 will give us 6, minus 4 will give us 2. Can you see? H2. That is it's following the what general formula. So what do we now call this guy? Obviously, we have to call this guy what? Because it's 3 carbon, we use what? Prop. Abina. Prop what? Propine. But that's not all. Let's not forget, it's a cyclo. So we have to add what? The prefix. The cyclo is the prefix, the prop is the parent, and the "-ine" is what? The suffix. "-ine" is telling us that it's an alkyne. Prop is telling us it has what? 3 carbons. And finally, our prefix is what? Cyclo. Cyclopropine. Now this guy, same thing goes for this guy. It's 4 carbon. 4 carbon, right? So we now call it what? Cyclo what? But what? Butane. Now, looking at this guy, obviously we already know what to do. Is what? Pent. It has the shape of a pentagon. So these things are easy. You just have to continue doing and you get familiar with them. Alright? So now we have this guy to be what? Cyclo pent. Point what? Pent. And remember, this is the what? This is the suffix. This is the prefix. And these guys are what? The parent name. Okay? So now this guy, this is where it gets a little bit fun. But it's actually easy. Now, after getting our cyclo, remember when they are joined together, it's called the cyclo. This guy is now, what do we now call this guy? Obviously, he will be called a substituent. He will not be counted among. Unlike when we have a straight carbon, any branch can be considered a substituent depending on if it's actually the longest chain or not. Okay, so now this guy is now a substituent. So from that, what do we know? We know that this guy is in alkyl group, and which alkyl group is that? Methyl. And now knowing that it's methyl, and it's 1 methyl there, so we just have to put what? 1 methyl what? 1 methyl. Obviously the cycle is what? Put 1 methyl what? Butane. Okay, that is how to name the cyclo alkynes. Now in the next video, please stay tuned. In the next video, we are going to be looking at what? The preparation. And in the upper video, we are going to be looking at what? Reactions of alkynes. Very, very important. Please like, subscribe, and share to your friends who you know are actually going to be in need of teachings like this. And thank you for watching.
Science. Okay. A friend that takes H2O every 5 minutes. Can you be friends with this person?
No,
Why?
because he's doing what's not good. So I cannot be friends because it's going to affect me. And whatever he's doing, if people know about it, they'll say me, so I'm also doing the same thing with him. True. So that's it.
Okay, what's your advice now to Nigerians that that have friends, that keep friends that take H2O?
I'm just going to tell them that they should avoid that person. And if they know they cannot, they should just at least find someone that can talk to the guy or the lady or anybody that can talk to him so that he's going to stop whatever he's doing.
Okay, what about you? Can you be friends with someone that the person has esophagus?
I cannot be a friend with that kind of person because actually, if I follow that person, it might affect me.
Okay, but do you have esophagus? No. Wow, nice one.